Hello friend, welcome in my channel IIT Civilanta, and today I am going to discuss about design of canal. There are basically four types of condition for which we have to design. First is the rigid boundary channel carrying clear water. Second one is the rigid boundary channel carrying water plus sediment, and third one is the alluvial boundary channel carrying water, and fourth one is the alluvial boundary channel carrying water plus sediment. So now in this module I am going to discuss about the rigid boundary channel carrying clear water. So what data we required for this purpose? So first we have to know the lining material. Based on that we can choose the Mannings coefficient, because generally in a rigid boundary channel we assume that the flow is a uniform flow, and whatever the principles and formulas which is applicable for uniform flow, which easily we can apply in this condition. So first of all we know flow, what is the discharge, what is the required amount to be passed through the canal. Then we know the longitudinal slope. We cannot change the longitudinal slopes, and this is our requirement, and roughness also we cannot change. Then fourth one is the side slope. If it is given, that's okay. If it is not given and repose angle is given, then we have to calculate the side slope must be less than or equals to repose angle, because the soil material must be stable. So we can get easily one vertical to z horizontal, and z is equal to cot theta, and where theta is the side slope angle. Here we can see side slope which is less than the pi. Pi is the angle of repose, or it is also called as angle of internal friction of surrounded soil. Surrounded soil means the soil which is nearby our canal. So the equation, the resistance equation, popularly known as the Mannings equation, which is we are using for this analysis. We have one of the equation is a Chassis equation. We can easily use that equation also, but the field engineer or professionals using Mannings equation, we go for that. So coming to the step number second, how to decide the cross section, which cross section we have to choose, whether it is a triangular section or trapezoidal section. So IS 4745 1968 gives the criteria how to decide the cross section. So if our discharge or flow is less than 55 cubic, then we go for the triangular section. So these are the formulas where based on that we calculate the area and perimeter. So and this is the area, y square in bracket cot theta plus theta, and perimeter, weighted perimeter is equal to twice y cot theta plus theta, and where it is you can consider that the angle unit of theta must be a radian. Okay, so and calculate the hydraulic mean depth which required for our Mannings equation calculation. Okay, so R is equal to a by p, which will get y by 2 for a triangular section. If our Q is greater than 55 cubic, then go for the trapezoidal section. A trapezoidal section with rounded bottom. Then according to the simple geometry we can calculate the area. corresponding weighted perimeter, then calculate the hydraulic mean depth. So we will get this value in terms of B and Y. Okay, so our next step is how to get our what does the design means. Design means to know the cross section means B and Y. Here we have to know this is our target. So for that, as we have area perimeter in terms of B and Y, some textbook prepare that just choose the B by Y ratio according to discharge and then proceed to our calculation. But here I have prepared Awasa book, Dr. K.L. Awasa book, in which what they did, they assume the velocity first to get the area velocity, but just blindly don't go for any value of velocity. Check this criteria. If you put this area perimeter value in this equation, Mannings equation, then you will get that this is the criteria which decide our value of H, which is a real or imaginary. So be careful about that. So for this we don't require H or B, so we will easily get this value. If you will get this value, assume the velocity which is less than this value, this U. Okay, then you will get that U value. You can easily calculate the area of section. Area is equal to Q by U, means you know the continuity equation. Q is equal to area into velocity, that, and hence you can get easily area is equal to Q by U. Okay, so you will get area, but still we have two unknowns and one single equation, means area is equal to by plus y square cot theta plus theta. If we get the P, then we have two equations, two unknowns. So how to get P? So coming back to the Mannings equation, in Mannings equation we have Q is equal to A by N R to the power 2/3 S raised to the power or half or square root of longitudinal slope. So we can easily write R is equal to A by B. So based on this calculation, we know flow, we know area, only unknown is P, so you will easily get the P value. So we have area, we have perimeter, we have area, we have. So two equations, equation 1, equation 2, you can easily get here. Area is equal to by plus y square cot theta plus theta, or perimeter, weighted perimeter is b plus twice y cot theta plus theta. Here you put the value of area and value of perimeter and solve for b and y. You can easily solve this equation. Otherwise, convert this equation. A is equal to b is equal to p plus 2y cot theta plus theta, and put this b into this equation. You will get the quadratic equation. You will get two values. One is you will get two combination, which value gives the real number, and b by ratio is real values. That will be your design solution. Okay, so rest of the designs we will discuss in second module. Okay, bye. If you like this video, please subscribe my channels and write down some comments so that I will improve my teaching. Okay, bye.